want to talk about, JS modules. So you will encounter more with JavaScript modules in the browser side in this Lab 7, and then almost everything that we do on the Node side will be dealing with modules as well. So I just want to illustrate that this is a general specification of JavaScript. It's available to us at the front end and the back end. And I think you will agree after this lab that this is a much cleaner and better way of organizing your code base for your front end component of your application. Okay. So I'll quickly go through just an introduction of modules and then how we look at them from the HTML level, how we look at them from the JavaScript level. We'll talk about exporting a module, importing a module, the default export, combining exports of default and name, and then aggregating modules. Okay, so as our applications grow bigger, and so I would just say, think of like, say, for instance, the platform, or even this most recent application is relatively decent in size. We've been making bigger and bigger applications. There's a desire where we want to split into multiple files. And so every time we create a different file, we can call that a module. A module may contain a class or library of functions for a specific purpose. So a module is just a file. That's all it is. One script is one module. It's as simple as that. Modules can load each other and use special directives such as export or import to interchange functionality, call functions of one module from another, or whatever. So export obviously allows you to export a data structure or a value or a function or a class or an object from outside of the current module, whereas import allows you to import some functionality from another module. And you can only import that which has been exported. So this is a two-way street. You can, effectively, it provides strong capabilities of encapsulation between JavaScript scripts. Again, what is a module? I already really mentioned this. This looks like a redefinition, so I'll just skip by. So why should we use modules? Well, there are many benefits to using modules in favor of having spaghetti code effectively, big sprawling interdependent code bases. Think back when we were doing the platformer, the number of script tags we had to go ahead and include and how the ordering mattered depending on what used what was dependent on what. So an implicit understanding of the dependency of all elements became a non-trivial task. And so modules allows us to abstract those concepts away. And just import into each JavaScript module what we need at any given time. So maintainability. By definition, a module is self-contained. A well-designed module aims to lessen the dependencies on parts of the code base as much as possible so that it can grow and improve independently. Updating a single module is much easier when the module is decoupled from all the other pieces of code you have. Other reasons to use it is for namespacing. JavaScript variables outside the scope of a top-level function are global. Yes. We've seen how the window object is the global scope. Modules do not include that global scope. So module scope is different than your traditional script. So it allows for a more encapsulated environment. Variables declared inside of a module are not defined within the global space. And this is actually going to be an issue we have to resolve in the lab. So every time you see one of the modules in Lab 7 access the window object, it's to register a module, something that's in the module space to become a member of the global space. So just because by default we don't have access to the module scope doesn't have access to the global scope, we can move data into the global scope if we choose, so that the event dispatcher can get access to a function, for instance. And so sharing global variables between unrelated code is poor software design. So using modules allows us to avoid that. And so the third reason why we should want to use modules is reusability. And let's be honest here, we've all copied code we previously had written before, right? I know I do it a lot. I'll copy a function and paste it back in. And so that's all well and good, but the much better practice here would be to encapsulate code that you normally would want to reuse, functions that you'd want to reuse into a module, and just import those in. So some quick differences between modules and our standard scripts, the way we have been using it. Well, first of all, we cannot load modules locally. We cannot use the file protocol to open up anything we label as a module. We'll get a CORS error, and I'll talk more about why that is in just a moment. So other ways that modules are a little bit different than the standard scripts we have been writing is that module features are imported into the scope of a single script. They aren't in the global scopes. I already mentioned this, right? You have a module scope and not a global scope. So it helps encapsulate all of the functions and variables that are not exported from that module. So it allows us to adhere to stronger object-oriented principles, actually. The this keyword within modules does not refer to a global this object. It's instead left undefined. And the new static import and export syntax that's available. Let me remove new because that's confusing. The import and export syntax is only available in modules. You do not get that in your scripts. So if you want to be able to import blocks of code or export blocks of code, functions, objects, or whatnot, then you have to encapsulate it in a module, which is why we're going to use modules in this lab. So a kind of technical understanding of what happens when a module loads. This is what happens in the JS engine. It goes through 4 steps. There's a parsing step where the implementation reads the source code of the module and checks for syntax error. Then there's a loading step where the implementation loads all important modules recursively. Then there's a linking step. So for each newly loaded module, the implementation creates a module scope and fills it with all the bindings declared in that module, including things imported from other modules. And then finally, there's the runtime, where the implementation runs the statements in the body of each newly loaded module. And by this time, import processing is already finished. So when execution reaches a line of code where there's an import declaration, nothing happens. This, I think, does not help the explanation much. So just, okay, let's look at modules from an HTML perspective. How can we actually declare that a JS file is a module and not a typical script? We just use the type here as an attribute inside of our script tag, our opening script tag of type, and we set it to module. That's it. It's that easy. Other than that, you use the same naming scheme, and all the implementations effectively the same. We just have to go ahead and import it into our HTML as type module. Now, like I said before, though, modules only work with HTTP. I'll give a little motivation as to why that's the case. JavaScript modules load multiple scripts more effectively by using the HTTP GET request to perform non-blocking asynchronous imports. However, the consequence of getting this performance boost is having to use the HTTP protocol to fulfill those GET requests without generating a CORS error. And so that's why we can't use the file protocol. If we attempt to use the file protocol, you will get an error. Okay, let's talk about using modules from a JavaScript perspective. Excuse me. So there's something that we will call module pattern. So the module pattern is used to mimic the concept of encapsulation across scripts, as I mentioned before, so that we can store both public and private methods and variables inside a single script without concerns of some global scope. That allows us to create a public-facing API, which is what our exports are for the methods that we want to expose to the rest of the world or the other modules that are part of the software system, while still encapsulating any private data that's not designed or not designed for external view. So there are module specifiers, and so when we import a module, the string that specifies the location of the module is called the module specifier. And so let's take a look at some examples. So before we can look at importing a module, we first have to look at exporting a module. We can't import that which has not been exported. So the export keyword can be used to export components from a module. Exports in a module can be classified as either a named export or a default export. We will look at both. Named exports, we can use two different syntaxes for. They're distinguished by their actual names, and there can be several named exports in a singular module. And so let's look at syntax 1 here as an example. Here, when we define a component in our module, and this component can be a function, it could be an object, it could be an array, it could be a value. So anything that essentially is stored as some type of data can also have as the keyword export, and it will get exported as whatever it is labeled inside of that module. Alternatively, we can declare all these as normal without the export keyword in each of these components. And at, say, for instance, the very end of our code base, we can do one big export using the export keyword and then packaging inside of essentially curly braces, define all of the named components that you wish to export. So these are the two different ways that we can have named exports come out of our module. Does this syntax make sense to everybody? I'm not going to have any live examples of this simply because I would have to go ahead and generate new files and then serve them through HTTP, and I didn't feel like going through that overhead. So I figured a quick explanation by some source code would be fine. But does the distinction between these two things make sense? And you will get a lot of practical examples of this in this next lab. You will be importing and exporting a lot. Okay, let's talk about how we can distinguish between these named exports versus a default export. So default export is when a module needs to export only a single value, or it wants to have some default export. Then we can say export default and then give the name of the thing we want to export as the default thing. Now, you can only have one default. You can have any number of named exports, so the things that just use the export keyword. But the thing that uses the export and default keyword, you can only have one. So let's talk about importing. There are three ways we can import that which has been exported from another module. We can essentially import them by their actual name. So we need to know the names that were exported. So here, when we exported this set of components, either in a collection of curly braces, so essentially we were kind of packing them into a structure here, or as an array here, or not as array, I'm sorry, as an object. So we're packing it into an object, or as we're naming it here, essentially what's happening with the named exports is it's creating an anonymous object that gets passed to anything that imports it. And so you can destructure that anonymous export object to grab its key value properties. And so the keys are going to be what the actual names were in the original module. So if I had component 1 and component 2 and component n names here, then when I go to import, I would have to use component 1 and component 2 and component n from here. So I would use import and do what looks like a object destructuring with the names of each of the properties. And I would do that from, and then the name of the location of this module. And so notice you use a path and you use a string. You have to use .js to use this in the browser, and you have to use // to illustrate it's in the current directory, or .. / if it's in a parent directory. So you have to give a pathway, either relative or absolute, but it has to be in the form of a path on your imports. An alternate way is you can actually also give it a new name. So you have to import as the original name, but inside of these curly braces where you're destructuring from the property, if you use the keyword as, you can assign it to a new keyword, to a new value, to a new name inside of this new module. So you can either import based off of its name from its previous module, you import it with its original name, but you can assign it a new name using this approach. Or another way you could do this is you can import everything that is exported from the export object and give that itself its name. So for instance, you will see an example of this in Lab 7 using the HTTP export. You will export based off of this asterisk, this like which will grab all of the exports and then allow you to give that, essentially allows you to name the exponent object. I'm sorry, the export object. I don't know why I keep on calling it exponent. This allows you to grab the export object and actually give it a name. Whereas in the second example, it's allowing you to grab the properties of the export object and give each of those individual properties a new name. Okay, let's talk about doing imports for the default export. So the nice thing about the default export is we don't have to destructure it because we're actually exporting it with just that property name. So that in this instance, for the default export, we're actually it's not an anonymous exponent object that's passed, that it's actually has the label of the thing that is being exported as. So in the instance that I did a default export with something called any variable name, then I can just import that any variable name just like so. And again, you will see this inside the lab. That will be the distinction actually between those imports that are using curly braces and those that do not. And I'll give an example, a small example, at least on the slides that will highlight that. So let's actually look at real world examples. Suppose that we created a module or even a file, a JavaScript file that's called company1, and it has this variable company foobar. Now foobar, since it is not exported, is not available to any script or module that's outside of this module company1. Now we can create these two functions, company, get company, and set company, which will return the company's name by uppercase, and set company will take a new value and set this company name. And in fact, we will export these two functions. So then inside this other file, let's call it company2, we will consume those exports from company1. And again, we can do this in one of three different ways. We have three different approaches. We can either use the original export names of company and get company from our module that we're importing from, and then we will log company and get company method calls, or we can give them new names. So inside the curly braces, when we import, we will assign as X and Y, and that way in our new module, we can access those as X and Y. And this third approach, as you may recall, is to give the actual export object a name of, say, for instance, my company. So now I can actually access any of the exports defined in that export object by that label instead. So my company.getCompany, my company.company. And so if I were to go ahead and then just put this inside of some HTML that imports the module that actually does the work, that does the processing, so that's company2. Notice I don't have to import company1 because company1 gets imported itself from company2. So the only dependency that my HTML relies on is the launch point of the application, the thing that essentially has the main method. And then the output would be exactly as we'd expect. Okay, so we already talked a little bit about default exports. Here's an example of it. Let's rebrand what we just did with the other code. Let's create a company1. It has this variable called name. It has this this object that has a get name and set name called company. Let's just go ahead and export company as the default export here. So notice it's the only export. Now, when I import, I don't have to contain anything inside those curly braces, right? I'm not destructuring an anonymous export object, I'm actually exporting the default. So since this is the default, it actually gets a name. And so I can actually go ahead and import that. So import C from company. C will automatically be branded as this default export. So then I could do c.getName, c.getCompany. And then finally, we can actually combine default and named exports. So say, for instance, I export this variable. I essentially can export anything that holds data. So variables, functions, arrays, classes. So let's export a variable, but let's also create a default export. We can do this. We can mix and choose. Now, if I do this, I have to import them the two different ways. I can import the default export with just the name, right? So I can just put C here. I would have to import the named export by using the actual property name or the exported name that it was given. So with the default, I can give it whatever name, right, without having to destructure it and use its property name, its export name. But with the named exports, I need to be more precise in the way that I access it. However, the strength is I can have any number of export keywords. I can only have one default. So in this instance, I can actually access both the default and the export, the named export, in the same module, and actually console log all of them. And the one last thing that I kind of want to talk about modules, so it gives you a little bit insight into them as you cover them inside of the lab, is the ability to be able to aggregate modules. So sometimes you might have a module whose single responsibility is to aggregate the exports of all other modules so that you only have to import one as opposed to importing many. So imagine that, I'll give you a use case on this. Imagine if you're building a code base and you're finding that there's a lot of similar imports you have to do from a variety of modules, where you can create one unified module. It's almost like, this is almost like inheritance. You can create one unified module whose one job is to import or export all the common modules that are used in other modules. So you could think of this as a main module that can, say, for instance, go to these various JS scripts. So imagine that in this particular application, it's something that provides lots of information on tea. So we might export tea and cinnamon from this one module, coffee and cocoa from this other module, and all of the exports from this other module. And so if I were to import this world food module, by importing this module, it gives me all of its exports together. So by importing this one thing, it's the same as importing all these three things in isolation. So again, it's just an easier way to be able to use modules to get a much more object-oriented way of managing our actual scripts in and of themselves. And making the way that we manage our code base much more organized and seamless and maintainable and extensible and readable and browsable. Okay, that's it. Is there any questions about either modules or by asynchronous JavaScript, or does this make sense thus far? And again, these are concepts that are not only relevant towards what we've done in the browser, especially in the last couple of labs, in Lab 6 and Lab 7, especially Lab 7, we've seen all this. And you can imagine how these concepts could have been beneficial for implementing Lab 4, which was the platformer lab. So is there any questions before I move on from this? I will give 30 seconds to issue any questions. So this, or let me ask this instead. Does this make sense thus far? And again, it should make more sense. It's one thing to talk about it and kind of understand what I'm saying. You'll get another experience with this by actually stepping through this with the lab. So again, I design all the lectures to have a companion lab so that you get to hear me talk about it, then you get to experience, and then finally a companion homework so that you actually get to do it. Okay, perfect. Okay, so the last thing I want to leave off with today, so this really ends our concepts as they relate to front end until we hit React. But React certainly benefits with us knowing a little bit about Node and NPM.